Hi guys, so in this lecture I'm going to tell you about what the shape function of an 1D bar element in a natural coordinate system and shape function for 2D element, okay, in a local coordinate system. Okay, so here this is module 2 syllabus. Okay, so this is very important. Okay, so derive the shape function for 1D bar element in natural coordinate system. Okay, so this shape function for 1D bar element we can derive in the all the three coordinates. Okay, so that is in the global coordinate system and natural coordinate system and local coordinate system. Okay, so among all these three, okay, in examination they may ask you anyone. Okay, so here I'm going to use the natural coordinate system. Okay, I already told you natural coordinate system means what. Here the maximum value is 1 and minimum value is equal to -1. Okay, the sum of the summation of the both the shape function which is equal to 1, that you have to remember this. Okay, in a natural coordinate system the second point, what the main thing is here, the origin will be start center of the given element. Okay, that is most important. Okay, in natural coordinate system. Okay, so this is very important question. Okay, so question they may ask you like this: derive the shape function for 1D bar element in a natural coordinate system. Okay, so already I told you the what you mean by shape function here. Okay, shape function is nothing but what, it is a to find the field variable in the given present element. Okay, so that may be either 2D element, 3D element, whatever that. Okay, even the higher order element we can also derive the shape function. Okay, so here I am considered a 1D bar elements. Okay, so this is a 1D bar element. Okay, so here the nodes are present. How many nodes are there here? Okay, two nodes are there. Okay, at node number 1 and at node number 3. Okay, so below figure shows the 1D bar, the D nothing but dimension. Okay, one dimensional bar element having a two nodes, at each node having there is a single degree of freedom. Okay, so consider a one dimensional element. So here the node number 1, this is node number 2. Each node the displacement is u1, at node number 2 displacement is u2, and this is the maximum values. This is xi or zeta is equal to 1 and zeta is equal to -1 at node number 1. Okay, so in the natural coordinate system I already told the axis will be present middle of the center or center of the given element. So here the we are going to start the origin from this point, that is zeta is equal to 0. Okay, from this point to this point the value is going to take the positive value, that is +1, here -1. Okay, so here, okay, so here we are, what is the question here? Shape function is there, so draw here, we want to derive the shape function from this point means. Okay, so draw one horizontal line here. Okay, from this point to this point let us assume x1. Okay, let us assume a length is x1. Okay, from 0 to 1 and 0 to 1, that is at node number 2 is length is x2, and here the 1 to 2 is length is what, x2 minus x1. Okay, so let us assume this is the displacement. Okay, so let u1 and u2 be the displacement at node number 1 and 2, and n1 and n2 be the shape function at node number 1 and 2. Okay, so here the zeta or xi value is what it denotes the natural coordinate having the value of minimum is -1, maximum is +1. Okay, at node number 1 and 2. Okay, so we need to calculate the shape function at this point. Okay, so that is what here 2 means n1 and n2 need to calculate here. Okay, so assume the polynomial displacement model function as this u is equal to a0 plus a1 zeta. Okay, so give equation number 1. Okay, so this is a 1D, since it is a given problem is 1D bar element, that is assume polynomial function which is equal to u is equal to a0 a1 plus zeta. Okay, so where a1 a0 and a1 are what I already told in the module 1, that is Rayleigh-Ridge while solving the problems on Rayleigh-Ridge method. Okay, so where a0 a1 all those are called what, generalized coordinate system. Okay, that you need to calculate with the help of applying the boundary condition. Okay, so here at node number 1, so what are the boundary condition at node number 1? So let us assume u is equal to u1, at node number 2 u is equal to u2. Okay, so length is what, x is x1, and length is equal to what, at node number 2 is equal to what, x2 minus x1. Okay, so at node number 1 u is equal to u1 and zeta value is -1. So okay, you have to remember this. At node number 2 u is equal to u2 and zeta value which is equal to 1. Okay, so using the equation number 1, okay, substitute in this equation. So both the boundary condition you are going to get these equation. Okay, a1 is equal to a0 minus a1 and u2 is equal to a0 plus a1. Okay, so u1 is equal to a0 minus a1, give equation number a, and u2 is equal to a0 plus a1. Okay, so these two boundary conditions you substitute in this equation, so you are going to get the two equations. Okay, a and b. Okay, solving these two equations you are going to get a0 value and a1 value. Okay, otherwise you can subtract, addition, to whatever you want to simplify, you need to, your aim is what, our aim is to find a0 and a1 value. Okay, so here after simplification by using a and b equation, so u0 is equal to u1 plus u2 divided by 2, and a1 is equal to u2 minus u1 whole divided by 2. Okay, so again just you substitute this a0 and a1 value in equation number 1, so that is in this equation. So u is equal to a0 plus a1 zeta, so you are going to get u is equal to u1 plus u2 whole divided by 2 plus u2 minus u1 whole divided by 2 zeta. Okay, so again you just you rearrange this equation. Okay, so okay, so u is equal to what, so 1 minus zeta, okay, divided by 2 u1. Okay, so plus here, so u1 is common is there. Okay, so you just to replace here, just to resimplify this. Okay, 1 minus zeta whole divided by 2 u1 plus 1 plus zeta whole divided by 2. Okay, so again this you can write in matrix form. So that is u is equal to half of 1 minus zeta 1 plus zeta. Okay, so into displacement. Okay, this is the displacement value at node number 1 and 2. Okay, so let us assume this is equation going to be assume n1 is equal to, okay, 1 zeta by 2 and 1 plus zeta by 2, that is which is equal to n2. Okay, so this n1 and n2 are called as shape function. Okay, so where n1 is equal to 1 minus zeta by 2, n2 is equal to 1 plus zeta by 2. Okay, these n1 and n2 are called as what? The shape function of a given 1D bar element. Okay, so this is very important to solve the numerical problems. You have to remember this. Okay, so n1 and n2 are called as shape function. Like this you have to derive the shape function for 1D bar element. Okay, so this pictures or this image shows the variation of the shape function n1 and n2. Okay, so at node, so look at here. So at node number 1, so maximum value is 1 is there. Okay, suppose you take the maximum value is 1. Okay, otherwise you substitute zeta value is equal to here. Okay, so n1 is equal to 1, so here from this point to this point maximum value will be there. Okay, so at point 2 other nodes is 0, so you have to draw the like this linear one. Okay, at node number 2, so here again zeta value substitute here, so n2 is equal to 1, so here from this point to this point n2 is equal to 1, other point is 0, because the maximum, the sum of all the shape function which is equal to 1, so that you have to apply the conditions here. Okay, so and the combination of these two diagram is there here. Okay, so this is n1, this is n2, and n1 shape function maximum, n2 function. Okay, so combination of this. Okay, these pictures are called as what? Variation of the shape function of n1 and n2. Okay, so like this you have to derive the shape function for 1D bar element. Okay, so n1 is equal to 1 minus zeta by 2, n2 is equal to 1 plus zeta by 2. You have to remember this equation for 1D bar element, that is called as shape function of 1D bar element. Okay, like that you have to derive the shape function for 2D bar element. Okay, that is derive the shape function for 2D bar element in local coordinate system. Okay, so you can derive, if nothing is asked in the examination, means you can derive any one coordinate system, either global, local or natural. Okay, so here the second derivation is derive the shape function for 2D bar element in local coordinate system. Okay, I already told you in the local coordinate system means what is the notation in the local, what is the what is the difference between local coordinate system and natural coordinate system? I already told you in the local coordinate system the distance what where we are going to take the axis. Okay, so here look at here in the local coordinate system, here look at otherwise you look at here in the natural coordinate system, where is the center? Okay, so here natural coordinate system, the center is what? The middle. Okay, in the this one in the what the local coordinate system means what? You are going to take the axis along the element. Okay, so here look at this is the triangle element. Okay, each node having 2 degree of freedom. So here the x1 of y1 x2 of y2, and this is 3 of x3 comma y3. Okay, just one. Okay, so let the a1. Okay, so look at here the length L1, here L1 L2 L3 are what? The shape function for the given 2D element. Okay, so here 3 nodes are there, so L1 is equal to a1 by this area. So okay, so this area by original area, and L2 also same, a2 by a, and L3 is equal to a3 by a. Okay, so the total area is equal to what? A is equal to what? Area a1 plus a2 plus a3. Okay, so if you want to find the shape function, the area of the triangle can be written by using Cartesian coordinates considering the x and y value. Okay, coordinate for the arbitrary point P inside the or on the boundary of the element. Okay, so a is equal to half of 3 coordinates will be there, 1 1 1 x1 x2 x3 y1 y2 y3. Okay, so like that I have to remember a1 also, 1 1 is equal to x y x2 y2 x3 y3. Okay, so again coming to the second element, so area of second a2 is equal to half of 1 1 1 x y. Okay, x3 y3 x1 y1. Just you here if you are not there 1 means you write here this one. Okay, so a3 is equal to half of 1 1 1 x y x1 y1 x2 y2. Okay, so look at here that this is the total area. Okay, so if you want to find the a1 area, means where is a1 area here? So a1 area is equal to where? Here. Okay, so here present is what? x2 y2 x3 y3. Okay, so here x2 y3, like that you have to write this a1 a2 a3. Okay, so after that what are the shape function? How to write the shape function for all those elements? Okay, so L1 plus L2 plus L3 is which is equal to 1, that is the shape function for some of the shape function for any element which is equal to 1, that is the properties of the shape function. And L1 of x1 and L2 of x2 plus L3 of x3 which is equal to x. Okay, this is the second coordinate system, L1 y1 plus L2 y2 plus L3 y3. Okay, so x and y coordinates, 3 elements, 3 nodes will be there, 3 direction you have to write x and y. Okay, so these 3 equations you write in the matrix forms, you are going to get this equation. Okay, 1 1 x1 x2 x3 y1 y2 y3. Okay, L1 L2 L3 1 x of y. Okay, if you multiply it means you are going to get same answer. Okay, so just you rearrange this, write in matrix form. Okay, thus if you transpose of this, okay, write down the transpose of this L1 L2 L3, these are called as shape function. So transfer of this means opposite of this. Okay, So write down here transpose, that is 1 divided by transpose, nothing but 1 divided by. Okay, so 1 1 1 x1 x2 x3 y1 y2 y3 1 x y. Okay, so after finding the inverse of we have, okay, so this inverse, how to find the inverse means I given detail in the lecture notes. Okay, so you have to take the there. Okay, so inverse of nothing but what you have to skip. If you suppose if you are calculating this first element means, so this one and this one you have to skip and write down. Okay, so this one, this remaining word you have to write down those remaining values inside the element. Okay, so l1 l2 l3, so write here 1 by 2a. So here 1 by 2a is equal to what? If you write the first one means you have to multiply this. Okay, that is called the inverse, x2 y3 minus y2 x3, like that you have to write down. Okay, so inverse of the, like that. Okay, if you are writing first your means you leave it this x2 this into this minus this into this. Okay, like that you have to write down this matrix. Okay, so this is called the inverse of matrix. I think it is there in the notes. Okay, lecture notes, step by step formula also wrote down there. Okay, so just to remember, I will tell you this x2 y2 minus x3 y3 means, if you are considering the first element means, so multiply this and this. Okay, x2 y2 y3 minus y2 x3, like that. Okay, suppose if for y2 y3 y2 this into this y2 y3, if you are writing means, okay, what, how you are going to write y2 minus y3. Okay, so here so this into this, if you are if you remove this means x2 means y2, so this into this into this y3. Okay, so this second row second column, if you are remove is y2 minus y2 into 1 is y2 minus y3. Okay, y3 this into this. Okay, write on here y3. Okay, so like that you have to calculate this. Okay, so if you form this. Okay, so after this, after finding the inverse of this matrix means, so we are going to get the variation of, that is the total shape function, what, integration of a, that is l1 of p and l2 q and l3 r, so three direction p q r into the area. Okay, factorial of p q r, okay, whole divided by p plus q plus r plus 2 factorial. Okay, so factorial of p plus q plus r plus 2 and into 2a. Okay, so the variation of shape function for this element l1 and 2 l3 are what? So this is how the shape functions are varies here. So from this point to this point, this is what l1. Okay, and this point the shape function will be maximum from this point. And the third element, okay, look at the third node, so this point will be the shape function is maximum, others two are 0. Okay, so look at here, this is a if you consider only the blank triangle. Okay, so from this point to this point, so here maximum, so remaining is 0, so just to join the linear word. Okay, so like that you have to draw this, what, you have to calculate the shape function for what, all the elements. Okay, so you have to in this the second derivation, only thing is you have to remember this. Okay, how we are going to calculate the inverse of matrix. Okay, so that is a determined by, that is what, a by in determinant of a. Okay, that formula you have to remember here. Okay, so like this you have to calculate the shape function for 1D bar element and 2D element using what, natural coordinate system and local coordinate system. Okay, so I hope you understand this. Okay, so how we are going to derive the shape function for 1D bar element and 2D bar element. Okay, thank you.